Okay, hello everybody. Today we are going to see the depth first traversal of a graph, and this is a very important topic as from a perspective that if you don't know this, you are not going to solve the deeper problems of the graph. So you should get this clear. Okay, let's first see what is the DFS traversal of a graph. So DFS, as the name suggests, depth first traversal. Let's see. This is a graph, right? So what is the DFS traversal of this? So 0, 2, 4, 3, 1. Mind you, this is not the only DFS traversal that we can get. Let me show you what I'm talking about. So let's say depth first. Okay, we are at a 0th node. Here they're telling us to start from the 0th node. Okay, let's say we are at 0th node. Okay, who are its neighbor? 2, 3, 1. Where do we go? Let's say we go 2. Okay, 2. What are your neighbors? 4. Just 4. Go depth 4. 4. What are your neighbors? Oh, no neighbors. Get back. Get back. 0. Let's explore the next neighbor of the 0. 3. Okay, 3. Your neighbors? No neighbors. Get back. Get back. Neighbors? 1. So as you can see, 0, 2, 4, then back, then 3, then back, then 1. Right? So as we have seen in trees, right? Whenever we talk about the depth first traversal, so we think about recursion, right? And when recursion comes, so there are two ways to do any depth first traversal, right? It's either using a stack or using recursion, right? So let me just clarify. This can also mean a DFS traversal. So if it would be 0, 1, then back, then 3, then back, then 2, then 4. So 0, 1, 3, 2, 4 would also qualify as a depth first traversal, but since they have specifically mentioned that we need it from left to right, so I'm assuming they're talking about just this traversal. So let's see. Let's first do it iteratively, so we can have a better idea of how the DFS works, right? So first of all, we are going to need a stack of type integer, right? Then let's make a set, because let's say we are, since 0, when let's say we are at the 0th node, right? We go deep down inside 2, right? And since this is a non-directed graph, when we are at a 2, we'll see, hey, 2 has 2 neighboring nodes, 0 and 4. So we don't want to go traverse 0 again, right? We don't want to print it again and again into our the final answer. So we'll make a scene set so that we can keep track of how much nodes or what nodes we traversed till now, right? So let's also make it integer, name it scene as set, right? Okay, and the final one we are going to use our let's name it as resultant, or we can name it as DFS equal to new array list, right? Now since we have to start with 0th node, let's initially push the 0th node to the stack. So we'll do stack dot push, and we'll push the 0th node, and we'll continue traversing this stack till it's not empty, right? Then if it's not empty, let's say, hey, what is my current node? Let's pop it, right? And if this node is not seen dot contains, right, current node, and not, if we have not seen this node, right, let's just add it to the scene first. So we say scene dot add current node, right? And also we need to add this to our resultant list, right? Add our current node, right? Then what are we going to do? So this is the first node. Now we have to see, hey, what are its corresponding nodes, you know? So since as I've said, there can be multiple traversal of this particular graph, right? DFS traversal, but since they're asking from left to right, as we know, our stack follows last in first out, right? So we'll try adding from right side so that our 2 gets traversed first, right? If we add the corresponding nodes of 0, 2, 3, 1, then 1 will get picked up first, and that's we don't want it according to this. I mean, that will also be a valid traversal, but not in this current scenario, current question, right? So what we'll do is, for int I equals, we'll say, hey, dot get zeroth node, right? Dot size, right? Say okay, before that we need to make we need to get those adjacents nodes of the current node. So let's make an array list, right, of type integer. Let's name it edges, since these are the edges of the current node, and we'll say, hey, dot get my current node, right? And let's not do this. Okay, so I want to traverse from right to left, from the end point. So basically from 1, 3, 2. So it's like 2, 3, 1, and I want to go from backwards, 1, 3, 2, right? So let's say edges dot size -1 to, where do we go? While I is greater than or equal to 0, we'll just decrement the I, right? And again we'll see, hey, if it's not been seen yet, right? If it's not been seen yet, then only add this to our stack and continue till our stack is empty, right? That's the whole idea here. Okay, we'll traverse till it's empty, and finally we'll return DFS. Let's try to see if it's running correctly or not. Okay, seen. I'm not sure, but while recording video, I always do these typos, right? See. So I'm more focused on how to explain it. So sometimes I miss these naming. Let's see, our it's correct. Let's try to submit it, and then we'll move on to the recursive part of the same code, right? We do have to understand how did we come to this recursion, and how are we approaching this question, just not mug it up, right? So let me explain it one final time. So we are taking a stack, right, and we are maintaining a scene, a hash set, right? We don't why we are maintaining that scene hash set, we don't want to traverse a node that has been traversed already. So otherwise we'll be in an infinite loop, right? let's say I am at a 0, right? I say, hey, what are your neighboring nodes? 2, 3, 1. Let's say I go on to the 2, then I go, hey 2, what are your neighboring nodes? 0, 4. If I don't add this 0 to the seed node, again I'll put it into the stack, and again I'll keep on going, and it will be an infinite cycle. That's why we need to maintain a scene hashtag, right? And then our DFS integer array list to store our final answer. And since the question has mentioned that we are starting from a 0th index, so we are pushing 0. Otherwise you can do any index that has been asked for, and DFS will change according to the index that you are starting. And while the stack is not empty, we'll pop the current element and check, hey, is it already been traversed? If not, just add it to the scene list and add it to our answer. And then go on to its neighbor, get its neighbor from the adjacency list, traverse its neighbor from the right side. You can do from the left side too, for my equal to 0 2. That would also be a valid answer, but since in this question it's been asked like that, so we're going to traverse from backward, since stack do the LIFO last in first out, so we want to traverse from the end so that we can get to first. We can get out 2 first, right? So again, while adding, check, hey, if this is not seen, then only add. We don't want to repeat, right? And then return. Alright, let's move on to the recursion part. Let's try to do it recursively now, right? It's basically the same concept, and since we are calling a recursive function, we need to call it from the start node. Hence we'll create a let's create a helper function, right? Or we'll call it DFS better. So public, we won't return anything, right? We'll call it DFS, and we'll say, hey, I need a start node, right? What else do I need? I need this adjacency array, of course, array list. So let's get this, right? And I will also need a boolean array of visited, right? I mean, in this case, either we can add as I did in the in the iterative section, either I can add it to a asset, or I can maintain a boolean array of size v, the number of vertices, and I can just mark it true and false accordingly, and let's name it as visited, right? Okay, so let's say what will so whenever we come to our current node, what we will say is, hey, my current node is the start node, right? And let's mark my current node as true, that is, I have visited this node, right? And let's add it to our resultant. Hey, I forgot to add a resultant list. Let's add a resultant array list, right? And we'll call it res, right? So okay, let's add this to my resultant array list, right? And now I have to add the adjacent vertices of this particular node, right? So what I'll do is, let's try it from int I equals 0, and when I is less than our adjacency list dot get current value, right? And get the size of that particular array. So let's say I have a 0th index, right? And in the 0 index I have 2, 3, 1, right? Let's get the size of this array, like how many nodes does it contain, right? And then I plus plus, right? And let's name it the next current. Hey, current next, right? Or I can name it just next. That would be more I think better, right? And then I'll say, hey, my adjacency list dot get current, right, dot get ith value, right? So if I'm at 0th node, so 0th adjacency, all the nodes that 0 is in with boundary with, and get that first element, ith element, since we are starting from 0, get that element, and right, and only add it if it's not being visited already. So if visited, right, and we'll put this inside, or we can directly, I think we don't need to put it inside since we have already incorporated a variable. If and only if it has not been visited, then only we'll recurse on this. So when we recurse on this, we say, hey, I'm gonna recurse on this next variable, right, and I'm gonna pass the same adjacency list, right, and I'm gonna pass the same visited array, right, and same resultant, right, saying that should do it. All right, let's call it from here. So we say, hey, we'll only have to make this resultant, rest all resultant and the visited. Let's not forget our visited array. Right. Of size v, right, and let's call our DFS function with start index as 0 as mentioned in the question, and adjacency matrix will be as it is, visited will pass it, right, and then rest, and then we will return the resultant. Let's try to run it, then I'll explain it once more. All right, seems like it's working fine. Let's try to submit it. All right, I've passed every test case. So let's go to the problem and try to explain. Okay, so this is our DFS function, and if we are trying to do it recursively, it will exactly work how our stack iterative solution work, right? So we are at a current node. We add this to our visited node and we add it to our resultant list. Then for every of this current's neighboring node, I want to recurse on that choice, right? And I want to only recurse on that particular node if and only if I have not visited that node, which I am maintaining this, right? So at every index, if I am visited, it's true, and if not, it's false, right? Then only I am, I'm saying, hey, DFS, let's say I'm at a 0th node, right? We have our neighboring index is 2, 3, 1, and then I go, hey 0, how many neighboring index you have? 2, 3, 1, right? So starting from 2, hey 2, let's recurse on 2, right? So as we'll go on to 2 is not in the scene list, we'll add it to the scene list and then add it to our resultant list. Then we say, hey 2, what are your neighboring? So 2 will say, hey, I have 0 and 4. But we will not add 0 as we are checking, hey, visited should always be false, but for 0 we have already set it to true, so it will not be traverse. We'll only traverse 4, then we'll come back, then we'll traverse 3, we'll come back, then we'll traverse 1, then we'll come back. Hence our order 0, 2, 4, 3, 1. You get it, right? So that's all about the depth first search of a undirected graph. I hope you get the clear understanding of both the iterative and the recursive solution, and both of it is very important to solve the further graph questions. All right, bye bye.